but with my 98. I'm going to take my 45-degree angle plus my 98 degrees, and I'm going to add that up. And I get 143. And guess what? I still have enough left over from my 180 degrees in my triangle so that I can make another triangle. So this triangle would have a different measure for angle A. If I subtract 143 from 180, I'm going to get 37. So my second triangle would be a 45, a 98, and a 37. So now that we have this information, I'm going to set it up and keep it a little more organized for you. So let's go back to our original information that we have, and now we're going to have triangle number 1 and triangle number 2. So remember that we just found out that for triangle number 1, the measure of angle C was going to be about 82 degrees. Then we found out that the measure of angle A was about 53 degrees. So the only thing left to find for triangle number 1 is the value of side A. For our triangle number 2, this is the one where we had the measure of angle C was equal to 98 degrees, which meant the measure of angle A was going to be 37. So now we also have to figure out, well, what A value would go with this one. So once we get to here, we're going to treat it just like our other law of sines problems. And I am going to use my original information whenever I can because I know it's correct. But now I do have to use this angle A that I found. So the sine of 53 over A. So I'm going to set up this problem. I'm going to cross multiply like we've been doing. The sine of 45 times A is equal to the sine of 53 times 10. To solve for my A, we're going to divide both sides by the sine of 45, so it'll cancel out. And when you do that, since we're finding a side, you don't need to do an inverse, right? We are going to get approximately 11.29. We could round that to 11.3. So I'm going to put that up in my chart. So I've completed triangle number 1. Let's finish triangle number 2 now. I'm going to use the sine of 45 over 10. This time I have to use the sine of 37. This is my angle A in triangle 2 over A. Cross multiply here. So the sine of 45 times A is equal to the sine of 37, fit this in, times 10. Divide both sides by the sine of 45, and we should get approximately 8.51. So one thing I want you to notice, and this is not a 100% sure way to check your answer, but on my first triangle, angle A was bigger than the triangle 2 angle A. And so my side length for A should be longer than my side length for A in triangle 2. Because remember that larger angles are across from bigger sides, smaller angles are across from smaller sides. So at least that part of the information checks out, and I feel pretty confident that I set up my problem and did it correctly. So this is an example of solving using the law of sines for the ambiguous case where we end up creating 2 triangles.